In this video, we're actually going to look at transformations. I am going to go over 5 different functions in Algebra 2 that you're going to need to know the transformations, and I'm going to show you a relationship between all of them. So I'm going to teach it a little bit differently than I would normally teach it, because this is kind of like a fast forward version of showing you the different ways that you can transform these functions and the ways that you can describe them. So let's start with 2 that you already know. Right in the beginning, I started with linear and quadratic because you already learned that in Algebra 1. You would have learned how the adjustments are made, how these transformations occur, and you can apply that to the rest of these functions. So I'm going to show you the connection in that in just a moment. But first, let me just show you a couple functions real quick and show you how I would describe them. The change, for instance. So I'm going to go over here, and this is my linear function, f of x is equal to x. So I'm going to type that in. I'm just going to put y equals x. Keep it real simple. Right there you have a line. And if I had a second function, right, we're going to do this second one, f of x is equal to x plus 5. So I'm going to go ahead and put y equals x plus 5. And notice that we had a change there. Now, looking at this, I just know intuitively, because I've done this a lot of times, that when I add or subtract a number to the end of a function, it is simply either going to raise it if you're adding, or it's going to lower it. And so this is a translation up or down. For instance, we were at origin with the original, and when I did x plus 5, which is now our blue graph, it just simply moved it up from origin to 5 on the y-intercept. So I went from a y-intercept of 0 to a y-intercept of 5. Therefore, it moved up. So what I'm going to do is I'm going to go ahead and write over here. I'm going to draw an arrow, and I'm going to say moved, or you know what, let me rephrase that. Let's not use the word move, let's use translated. So we're going to say translated up 5 units. So that's all that happened. When we added 5 to it, we translated up 5 units. I am going to draw both of these graphs. The original that I had went through origin right here, so I'm going to draw a line through origin. And again, this is just going to be a sketch, so it's not going to be a perfect graph. But there's my original line, and then the new one, the x plus 5, went up 1, 2, 3, 4, and 5. So it just moved that y-intercept through 5. Alright, so that we can see, and I'm going to draw an arrow that shows it moved up. Now if we would have subtracted, it would have moved down. And there's other transformations that we could have done as well. We're going to talk about those in a little bit more detail when we get to the end of the lesson. But this is just one example on a problem that you have on your sheet of you could explain what occurred, right? If you see some number being added or subtracted, you just say that it either translated up or it translated down, however many units that it did. And you can always put it in decimals to check it, or you can put it in your T84 graphing calculator and see how did that graph change. Let's go to another. Here we have a quadratic, and once again this is something you're familiar with. You've already done these transformations in Algebra 1. However, to refresh your memory, I'm going to graph both of them. And I think I'm going to graph them in a different order this time. I'm going to graph the red one first, because that way the color comes out on decimals red. So for instance, I'm going to type in x, and then I'm going to square it. Well, now it comes out green, so it's quite different. That's fine. Let's do x and then squared. Okay, so this is the original. I went ahead and did the black one, so x squared. And then we'll see what changed when we went to x squared plus 3. Now, before I do that, I am going to go ahead and just draw a graph, or I should say a sketch of a graph on my line real quick what this looks like. It looks like it goes through origin, and it curves up. So this is what it looks like right now. And let's go ahead and let's transform this. So I'm going to take x squared, and we're going to put plus 3 because I have a plus 3 there. So we can see what happens. Plus 3. And you can see this new graph, the purple one, all it did was shift up. In other words, it translated up. Well, how many units did it go up? Well, we added 3, and notice from origin, which is at 0, 0, it went up 1, 2, and 3. So our y value actually increased by 3 units. So what I'm going to do here is I'm just going to draw an example. We'll do 1, 2, and 3. I'll put a point right there, draw an arrow, and show that it went up. So for this, if I wanted to describe what happened, I would just say it translated up 3 units. So as you can imagine, if we would have had -3, it would have translated down 3 units. And I'll just show you an example of that. So let me go over here. I'm going to put -3 just so you can see. -3, it would have went down. And once again, we're going to go in greater detail in these in just a moment. But let's just get the basics down. So let's go to absolute value. Now this is a new function, right? You did not do absolute value in Algebra 1. It's going to look quite different from the quadratic and the linear equation. So let's go ahead and type it in. Now if you've never put in absolute value inside of the decimals calculator, well, let me show you how you do that. You go over here to where you see these brackets and they have an absolute value with an A in it. Just simply click on it. You can put your X in there. Click on it again, and now you have an absolute value function, right? So it looks like a V. So think about V for victory. So I'm going to go ahead and I'm going to draw that on my graph real quick. Now if you notice this one, I didn't add to it. If I would have added to it, it would have done the same thing as the quadratic and the same thing as the linear function. If I were just to take this absolute value of x and add 3 to it, it would simply move up 3 units. And I'll even show you that on the calculator right quick. Plus 3, notice it just goes up 3. If I were to subtract 3 minus 3, it just simply goes down 3 units. So I thought I'd do a different type of transformation here so you can see something a little bit different. I'm going to go in front of the absolute value and I'm going to add a 2. So I'm going to put 2 and I want you to watch what happens. Actually, let me rephrase that. Let's put another one in there so you can see the original and see what changes. X, click the absolute value again, and let's put a 2 in front of it. So there you go. So I want you to notice, right, the original is the black, and if you look, there is what we call a narrowing of the function. In other words, this function right here, we also call this a stretch. So it is a stretch inward towards the y-axis. So notice it's pulling in. So I'm going to go ahead and draw the new function. And this represents the 2 being multiplied to the absolute value. And I'm going to draw an arrow just kind of showing that it's stretching. And if I were to describe this, I would just go ahead and say vertical stretch and that would explain it. And it's just that simple. So if somebody asked you what occurred here, what did you see happen? Well, when we multiplied absolute value of x by 2, we had a vertical stretch. Now let's go ahead and let's take a look at a different one, right? A different type of function. And this is an exponential function. So let me go ahead and erase these real quick. And before I erase it, I do want to show you something. Let's say that we used a number that was less than 1 but greater than 0. So instead of 2, let's say we did it by 1/2. I want you to notice and see how this actually got wider. We actually call that a shrink. So in other words, it got wider. So we call that a vertical shrink, or sometimes they'll call that a vertical compression of the function. And the same thing would have happened if we were to put a number in front of the x squared for our quadratic function. So in other words, what occurs, in other words, if you have a number that's greater than 1 in front of the x, it's going to have a vertical stretch. If you put a number that's less than 1 but greater than 0 in front of the x squared on your quadratic, it's going to have a vertical shrink. So in other words, they have a relationship. They basically do the same thing, even though the shape looks different. So I'm going to close these out. We're going to move on to this exponential function. Now I did throw some numbers in here, so we just have a reference point to starting. Exponential functions are represented by a times b to the power of x, where a is going to be your y-intercept, and b are what I also call your starting point or initial value, and b is going to either be your growth or decay factor. Now, you learned a little bit about this in Algebra 1, but you didn't really look at transformations of it. You just used it to make predictions. So if I go down here, I'm going to put 1 for a, and I'm going to put 1/2 for my b value to the power of x, so we can see an example of what 1 would look like. So I have 1 times 1 divided by 2. That gives me my 1/2. And I'm going to close that, and then put that to the power of x. So to the power of x. Alright, so you can see here we have our exponential function. And this is exponential decay, as what you would have learned in Algebra 1, because as the x value increases as you're going to the right, the y value decreases. So you can see it curves to the right and down as it goes over. Now let's go ahead and let's do this transformation right here. Let's change it. Let's put a 2 in place of a, and we're also going to go ahead and change it to a growth factor. So we're going to see a couple changes occur. So I'm going to come over here, and actually, you know what? I'm going to keep the b value 1/2. Even though I wrote a different number, I want to keep it 1/2 so that you can really see what happens. So now I'm going to go ahead and close this, and to the power of x. Now, hopefully you're looking at this and you realize this green one is the new one, and hopefully you see that something occurred here. We had some movement, right? And so when we're looking at this, I hope that you realize that by changing the a value from a 1 to a 2, we had what we call a vertical stretch. So notice, right, notice it kind of, look at this blue line, it's further away from the y-axis, and you can see the green pulled in. So I'm just going to draw these two examples real quick. And you know what, on the notes, I'm just going to change this real fast. Let me update this. I'm going to put 1/2 in there. That way we're just looking at one change at a time. And so I have 1/2. So I'm going to draw the original. Now my original was the blue line. It looks like to me it crosses at +1. So I'm going to put a couple bars on here. And we'll put a point here at +1. And we have our line coming over. And then it goes up. Now with the new one, right, the green one, notice our y-intercept is now moved to 2. So that is your y-intercept, that value of a right there. So we went from a y-intercept of 1 to a y-intercept of 2. So I'm going to go ahead and draw it in a little further. Put a dot right there at 2. But it does go back down, and they both hit like that. Okay, so if you notice on this right here, right, looking at it initially, you might have said, oh, it moved up. And that is true. We did have a change in the y-intercept. However, this graph actually pulled closer to the y-axis. So we're going to say that we had a vertical stretch once again. And again, I'm trying to show you that we do have a relationship here. Notice over here, when we multiplied a number that was greater than 1 to our absolute value, we had a vertical stretch. When we multiply a number greater than 1, right, for our a value to this function, we also have a vertical stretch. So we have similar things occurring. And the same thing would have occurred if we put a 2 in front of 2x squared, right? Or if I put it in front of the linear, we would have had a shift in slope. And the line would have tilted up towards the y-axis and became more steep. So let's look at one more function that we need to look at that you're going to be analyzing while you're in Algebra 2. Now this last function that we're going to look at, notice it says f of x is equal to 1 over x and f of x is equal to 2 over x. So this is the last one we're going to check out. And on this particular function, let me go ahead and X these old ones out. We're going to draw both. So I'm going to start out by putting 1 divided by x. And so you can see how this looks right here, this purple graph. And I'm going to go ahead and attempt to draw a sketch of that over here. So it looks something like this. Now, I'm going to go ahead and graph the second one so we can see, well, what happens when we put a 2 in our numerator. So we change this 1 to a 2, what occurs? And just so you know, putting a 2 in the numerator is the same thing as multiplying 1 over x by 2. In other words, if I were to take, just to show you what I did here, f of x is equal to, and I said, well, okay, well, I'm going to take a 2, and I'm going to multiply that to 1 over x. Then this new function becomes f of x is equal to 2 over x, because the 2 gets multiplied to the 1, right? And if we turn this into a fraction, 1 gets multiplied to x, therefore we have 2 over x. So once again, we're simply changing what I call the a value. The value that is in front of this fraction, we are changing it. We put a 2 in front and multiplied it, and that's how we got 2 over x. So notice it caused a vertical stretch in the last two graphs that we did, right? Over here, we noticed that we did a vertical stretch when we multiplied the absolute value by 2. We had a vertical stretch when we multiplied the exponential function by 2. And now that we have this function, we multiply it by 2, and we see the same thing occur. So what I'm going to do is I'm going to go ahead and type that in. So we have 2 divided by x now. And I want you to notice that this pulled out. Do you see that? The new one is black. And so once again, we had the same type of event occur. We had what we call a vertical stretch. And so I'm going to draw the new one. So this new one, the line looks almost identical starting out, but when it starts getting down here, it stretches outward. And we had the same thing occur here. Starts practically the same, but then stretches out. And then lines up with this one. So I'm going to draw just a small arrow showing it going out, and I'm going to label this as a vertical stretch. In other words, it pulled out just a little bit. Now, we've seen these relationships here, and you notice I kind of wrote this cheat sheet here. I chose to use A, H, and K so that you could kind of see what letter has what effect on the graph. And we're going to look at some different images. I'm going to do some more examples here. So if I'm looking at it, for instance, when it comes to the linear, it's not as obvious always with that when we change it. Most of you, if you looked at it, for instance, I'll just give you an example. Let's say we said we're graphing just simply y equals x. So I'm going to type that in, y equals x. Right? So you're looking at just a line. Now, if we were to change that number in front of it to a number greater than 1, let's say we did 5. So y equals 5x. We do have what we call a vertical stretch, because notice this line is pulling over to the left. Do you see that? It's pulling over to the left. It's getting closer to the y-axis, and so it is a vertical stretch whenever we have that number in there. And if you notice the a value, I have on here that it does two different things. It either creates a vertical stretch or it creates a shrink. In other words, the line either gets further away from the y-axis or it gets closer to the y-axis. I'll just show you an example of one that would make it get further away, what we would call a vertical shrink or compression, which makes it wider. If I were to say instead of 5, I did the opposite. I did 1 over 5, right? So now a fractional value. Look at how far this line is pulled away from the y-axis. So that was a compression or a shrink. And this is with something linear. So let's get rid of linear. And let's go back down here and let's look at something that's a little bit different. So I'm going to go ahead and let's do a quadratic. So let's say we had 2, and we're going to go ahead and put times x squared. And so you can see how this looks, right? And let's make it bigger. Let's say 5. It even gets more narrow. And we're going to use this 1/5 on all of them so you can see what would happen. So that's how one of them looks, right? I'm going to open up the second one. And now, instead of doing that, I'm going to do 1/5. So I do 1/5 x squared. And you can see how much wider it's got, right? So when we did a number that's less than 1 but greater than 0 for our a value, which is down here, we create a vertical shrink or a compression. On the other hand, when we have a value that's greater than 1, we create a vertical stretch, which means that it becomes more narrow. It draws in towards the y-axis. So that was with a quadratic. So far we've done a linear, we've done a quadratic. Let's go ahead and let's see what it looks like here on this rational function. So I'm going to go to the rational function. And if I take that a value, so we already used 2, so let's try a different one. Let's say we had 5. And then actually, you know, first I'm going to go ahead and put 1 over x. So 1 over x. So you can see what it looks like. And I'm going to transform it real quick. I'm going to put a 5 in front of it. So 5 times 1 over x. Actually, let's go here. Let's put 5. Put a 5 in front of it. And you can see, right, that we had this same thing, right? We had this vertical stretch occurring. And now let's go ahead and show you what it would look like if we were to shrink it. So I'm going to do 1 over 5 on this one. So I'll put parentheses, 1 divided by 5. Oh, somehow I accidentally put a 9 in there. Let's go ahead and put my parenthesis. Okay, so you can see what that looks like. So you can see instead of a stretch where it came out with a red, it did the opposite, right? We had a shrink. It actually pulled in closer to the y-axis. In other words, it's going this way towards origin. And you can see it curving in there. So I'm just going to draw a few examples on here. We're doing this right here. And I would recommend, if you're watching this video and you're trying to understand these, I know your teacher is giving you notes as well, and some of you are struggling with them. So I'm going to go ahead and you can use these notes as well just to assist you. And you can experiment with things with Desmos to see what's happening. And I'm going to draw this, and I'm going to write on it stretch. And then over here, shrink. Right? So if it's pulling out, we have a shrink. If it's pulling in, we have a stretch. And that's just one graph. I'm not going to draw all of them on there because there's not enough room. But that way you have an idea, right? If you see it pulling into y, you know that it's a compression or shrink. Close that out. So we did the quadratic, we did the linear, we did the rational. Let's take a look at the absolute value. So let's take an absolute value. I'm going to use the same number, 5, and put my absolute value. I'm going to put x, close it, and we can see, right, that we had a vertical stretch. It is pulled in towards the y-axis. And then we'll do one that has 1/5. So 1 divided by 5. And then I'll go ahead and use my absolute value symbol, put my x in there, and close it. And you can see that, right, it's pulled away really far. So we had a major compression. So we had a vertical shrink or a vertical compression. Because we're being multiplied, a is being multiplied to that absolute value, and a happens to be less than 1 but greater than 0. When a was greater than 1, right, then we had a vertical stretch. So vertical stretch, if a is larger than 1, we have a vertical shrink or compression if a value is less than 1 but greater than 0. So I'm going to go ahead and show you another one. So we're almost done now. The other one that I would like to show is I'm just going to go ahead and go down here right quick to our exponential function, and we'll just look at an example for that. And and we can use 5 again. So let's go ahead and use 5. So let's say we had 5, and we'll go with the number we were using earlier, 1/2. And I'm going to put that to the power of x. Okay, so you can see how this looks. I'll go to the next one, and we'll do 1/5, just so you can see the difference. So again, this top one right here, we're having a vertical stretch. And on this bottom one, we had a vertical shrink. Also notice, right, our y-intercept changed. Our y-intercept was 5. Now our y-intercept is simply 1 over 5, right, or 0.2 if we turn it into a decimal. So you can notice on this one, it came closer, right? The green one, notice it is much closer to the y-axis. And notice that the purple one, it is much further away. So it's a compression or a shrink versus this one right here, which pulled closer to the y-axis, which is a vertical stretch. It became more narrow, in other words. So that's all with A. I think we're done with A, that you understand that the A value, right, the number that's going to be in front of each one of these functions that's being multiplied to it, that it has an effect on it. And now I want to go to one that's really, really simple. Not a lot that needs to be said about it, but it's a reflection, right? So reflection, right, means we're going to flip it over an axis. And I want you to notice that right here, if we take A and we make it negative, and notice I have this positive negative sign in front of each one, all it'll do is just flip our line over, or flip our image over the x-axis. So let me show you what I mean. One that's real easy to see is going to be the quadratic. So I'm going to put the quadratic first. So let's say we have x squared. And I'm not even going to add any numbers to it. I'm just going to put x to the second power. You see how it looks right now. And if I wanted to make it negative, so do negative x squared, watch what happens. Do you see how it just flips down? So we had a reflection over the x-axis. So let's go ahead and try it with another image. Now, and I'm just going to add them on here so you can see the same thing happens. Let's do the absolute value. So we're going to go to absolute value. I'm going to just put in absolute value, close, and you can see that we have this V, right? And it points up, just like the original quadratic that was positive. And so now we're just going to make one with a value that's negative. So I'm going to put negative absolute value of x, and notice all it does is flip down. Now I could do this with the rest of them. We're going to see the same thing occur over and over again. Anytime that we make it negative, we're going to have a reflection. And so let me close these out. We'll do just a few more. So let's look and see what this other one would look at, our rational function here. So let me go to it. I'm going to go ahead and do 1 over x. And I'm going to go in front of it now, and I'm going to change it to a negative. And so you can see how it flipped. And let's go ahead and do the exponential. So, right, we have, I'm just going to give it an a value. So let's say that our a value is 1, and we'll stick with the number we've been using. I'll say that 1/2 is the b value to the power of x, right? And so if I took that same thing, well, you can just watch the graph. You can see how it looks here. If I were to make it negative now, it just flips down. So again, we had a reflection over the x-axis. So let's do a line, right? A line, I think, is probably one of the harder ones to see when it comes to that. But if you watch, so let's go ahead and we'll just give it a slope of 1. So we'll just say y equals. Notice sometimes I'm not putting y equals. I'm just putting what's on the right side of the equal sign. Desmos will still graph it even if you don't put the y equals and you just put x in there. But here's our line. It's x. And watch what happens when I put a negative sign in front of the x. It just flips down, right? It went from a positive slope to a negative slope. I'm going to go ahead and just draw an image real quick. And I think one of the easiest image, or at least one of the ones I like to identify, absolute value and the quadratic are really easy to identify. So I'm going to show that normally this would be flipped up. And then if we went ahead and did our negative a, it simply reflects it down over the x-axis. So we're almost done. Notice we really only have 2 things left to talk about. We have our h and we have our k. So let's look at h. What does h do? And notice I got an h in here on all of them except for the linear. And that's because I think it would look a little confusing if I put it in there. But all the rest of these, I put an h in there. So what does that h do to the graph? So we're going to look at 3 different examples. And we'll actually look at 4 different examples. Let's start with the quadratic. Again, I think that one's something you're familiar with. It's easy to tell what's happening. So what I'm going to do is, notice I got x plus or minus h. So let's start by we're going to put a parenthesis, put an x, and let's start with adding to it. So I'm going to say x plus 2. And I'm going to close it, and I'm going to square it. So we can see what happened here. Now, remember, our parent function was just x squared. So the green one is the original, and the blue one is the new one. So what I hope you notice is that by adding 2 to x in our quadratic, all we did was move from origin over 1, 2. Right? And so you can see our point right there, negative 2, 0. And so all we did was shift our graph 2 times to the left, which seems a little odd because we're adding 2 here, but it moves it left. So when you add 2 to x, it actually moves it left 2 times. Now, if I were to add 3, it would move it 3 times. So I'll change it to 3. If I were to add 5, it'd move it 5 times. So notice it moved it over to negative 5. So whenever you add or subtract the number to x, it's simply either moving it left or right. So let's subtract 5 and see what happened, right? You can see if I subtract 5, it moves it the other way. It goes to the right. Now this is going to be the same when we deal with the other functions as well. There is going to be a horizontal translation, either left or right, depending on if we are adding a value to x or if we're subtracting a value to x. If we add to x, it shifts it to the left. If we subtract from x, it shifts it to the right. So let's delete these and let's just show you another one. Let's do our absolute value. So I'm going to put my absolute value. Let's do x and let's do plus 3. So notice when I did plus 3, the original, right? I should have put the original first, but let's put the original. So my original is here at 0, 0. But because this one I put x plus 3, all it did was move it over 1, 2, 3 units. So it moved it from 0, 0, 0 to negative 3, 0. Now let's say that I wanted to move it to the right. So I'm going to do a third one here. So let's say I did x plus 3. I'm sorry, I say plus minus 3. And notice all that does is move it over to the right side. If I would have put minus 5, it would have moved it to the right 5 times. Over here, if I would have put plus 6, it would have moved it to the left 6 times. So again, this horizontal change is h. If you add h, and we're gonna write a note on here. I want you to put that on there. If you add it, so I'm gonna put a plus sign, moves, almost put right, it moves left. And if you subtract it, it moves right. So on this one, we'll go ahead and put this graph. I'm going to put the original right here. And just show that it moved over to the right. Okay, I'm going to show you one more example of it moving left or right. Let's do one that may not be so obvious, right, as the quadratic and the absolute value. But let's go ahead and let's look at this rational one again, right? Because I feel like that's always a confusing one for me when I look at it. So I'm going to do 1 over, and I'm going to do x. Now, you can see how the original looks. There's 1 over x right there. And I'm going to do the second one. But this time, I'm going to go ahead and let's add, right? So remember, if we add, it moves it to the left. So we should have this graph move to the left. And I'm just going to pick a random number. Let's move it 4 units. So I'm going to do 1 over x, and I'm going to do plus 4. So now you can see that it shifted over 4 units to the left, right? So if I kind of go to the halfway point, actually this is a good point right here. I'm going to look right here. This is at 1, 1, right? So it moves over 1, 2, 3, 4. Now if I wanted to shift it to the right, I could just do 1 over x minus 4, and it would go to the right. So 1 over x minus 4. And notice now from here it shifted over 1, 2, 3, 4 to the right. So if we want to move it left or right, we just simply add or subtract a number from x. And that works with all the functions. Notice down here when we talk about the exponential, we would add or subtract from x as well, except for if we're adding or subtracting from an exponent. Let me just do one example on that one. So let's say we had our values. Let's say we had 1, and then we had 1/2. Close it, and let's go ahead and put our x in there. Now notice on this one's a little tricky. In order to get it to shift, I have had issues. Oh, let me go back. With getting the exponent, to being able to subtract from the exponent, because normally, well, I mean, normally you would be able to put it in. For some reason, this calculator seems to have trouble with that. So I'm going to put a -2 up here, and then I'm going to put an x in front. And then I'm going to go ahead and get rid of the x. That's the best way to get that to fit in there. And let's put one that didn't have the x -2, so you could see what it looked like. Like, in other words, the original. So let's do 1/2. To the power of x. And so notice here's the original, right? And we're just going to go to the y-intercept. I think that's the easiest way to look at it. Our y-intercept is 1. But notice on this one, I'll put x -2. I want you to notice it moved it to the right 2 times. And that's because when you subtract from the x, it's going to move it to the right. So it doesn't matter if it's the exponent, or if it's inside of absolute value brackets, or if it's inside of parentheses, or if it's in the denominator. If you want it to move to the right, you simply will subtract from x. If you want it to move to the left, you will simply add to x. So there's your several examples. And now we're going to go to our last translation, our vertical translation. And notice this said horizontal because we're moving left and right. Vertical means we're going to move up and down. So I'm going to delete these real quick. We'll do several examples. One example we've already done is with the linear. So that's an easy one to do, right? So y equals x. And if I wanted to shift this down, I could simply say, well, y equals x. And let's say we wanted to go down 3 units. I could just do minus 3. And you can see really easy, right? Here's my y-intercept at 0, 0. And I went down 1, 2, 3 units. And now I'm at 0, negative 3. So on this one, I'm going to go ahead and put, if we add, so I'm going to put plus moves up. And if we subtract, it moves down. So k, right, notice what I like about k, it's always at the end of the equation, right? So in other words, it's real easy looking at the end of the equation. I always think of it as my y-intercept when I'm looking at linear, right? It's my last value. And so that's going to move it up or down. And I'll just show you some examples. Let's go, let's do our 1 over x real quick. So 1 divided by x. So here's our rational function that to me that looks the oddest. And I'm going to go ahead and put plus 4. So it should move it up by 4 units. And if I looked at the original was right here. And what I'm going to do is I'm going to use this point of this curve right here because I think it kind of makes it obvious how far it moved. It's at 1, 1, the center of that curve. And now, because I put plus 4 at the end of it, it went up 1, 2, 3, and 4. So now it's at 1, 5. Right? So from here, if we add 4 to it, all it does is shift that graph up 4. Now, if I wanted to shift it down, I could subtract it. So let's shift it down 2. I'm going to put minus 2. So now if I go from here, I go down 1, 2 units. So k, right, moves it up or down. Let's do it with a quadratic real quick. So I'm going to go ahead and delete these. Let's throw in a quadratic. I'm going to put x squared. And for my next one, let's do x squared. And let's do plus 5. That moves it up 5 units. So notice it went from origin all the way up here to 0, 5. So we just went up 1, 2, 3, 4, 5. And let's say I wanted to move it down 3 units. I could do minus 3. And it simply just moves it down 1, 2, 3. So I'm going to draw the quadratic here. And I'm going to do the one that we moved it down. So we'll do 1, 2, 3. Show it moving down. And you know what? We probably should show one going up too. So we can move it up or down by adding or subtracting the k value. On the h, we can move it left or right. So I'm going to show some going left and right. We can reflect it. It can either be going up if a is positive or flip down if a is negative. And when it came to the shrink and stretch, right, on this one right here, if the number, and I should put that over here, we should put on there that if the number is greater than 1, we're going to have a stretch. So a is greater than 1, stretch. And then a is less than 1, shrink. A well, less than 1, but a is greater than 0, because it also has to be greater than 0. Okay, so that's everything there is really in a fast forward version of what you need to know about transformations. So play with it on Desmos, play with it on your calculator by graphing it, and use these types of descriptions when you're doing the problems where it says describe what transformation has occurred. Well, right, you just say it moved right 2 units, or it moved left 3 units, or it translated up so many units, or it translated down so many units, or it reflected over the x-axis, or there was a vertical stretch or vertical shrink. Now you should be ready to complete the rest of those problems on that worksheet that your teacher gave you.